All right, ladies and gentlemen, so let's take a look at letter C here. So when we take the absolute value of this alternating series, what test did you decide to do here to check for divergence or convergence? Polynomial test. So again, we got 2 plus 1 compared to the degree of the denominator, which is 2. So if the degree of the numerator plus 1 is greater than the denominator, what do we know about the absolute value of this alternating series? It is doing what? Diverges. So now you have to check for your conditional convergence. To check for your conditional convergence, remember you're going to have to see if it passes your alternating series test. So first we want to find the limit as k approaches infinity of 2k squared minus 1 over negative k squared plus 1. So what is the limit as k is approaching infinity? It is equal to negative 2. So does this pass your alternating series test? No. So since negative 2 is not equal to 0, it fails your alternating series test. You don't need to check for the decreasing if it's decreasing. All right? So by your divergence test, we know that this is going to diverge. So this alternating series, I know, is going to diverge. All right? Any questions on that? All right? Now let's take a look at letter D. Isn't this an interesting one? Negative 1 raised to k plus 1 divided by cosine of k pi. I kind of mentioned this cosine k pi a minute ago. So again, let's take a look at cosine k pi divided by k. What's happening here? When I take the absolute value of this, what series am I in essence looking at? I'm looking at the what? 1 over k. And what kind of series is this? This is your harmonic. So by your harmonic series, what's happening? Is this diverging or is this converging? Well, right now, all I know it's doing what? Diverging. Ah. Good observation, Ben. Well, let's suppose you didn't have the top of the page to refer to. But this is why the top of the page actually refers to this. So again, so now we have to check this for conditional convergence by your alternating series test. So the limit as k approaches infinity of 1 over k is indeed equal to what? This is indeed equal to 0. And then again, you have to check to see if it's a decreasing sequence. So 1 over k needs to be greater than 1 over k plus 1, and is that true? Yes. So this is an example where you're going to have the conditional convergence. Remember, ladies and gentlemen, when you are looking at a series and you've got cosines and sines in them, that could be an alternator. All right, so make sure, even if you don't see the negative 1 to the k plus 1, if you just see this cosine k pi, be on the lookout. That could very well be an alternating series there. All right, any questions on D? All right, one last thing and we're done. There is another test you can use. Last test, guys, and I'm going to break your heart. It is the ratio test for absolute convergence. We're still talking about absolute convergence. Obviously, ladies and gentlemen, if you're dealing with an alternating series, just like we use the ratio test for factorials or exponentials, if you have a series that's alternating that you recognize has the factorials or you have those exponentials, you can apply your ratio test. So again, works just like the double R's we talked about last class. Again, if you take the absolute value of u sub k plus 1 and divide it by the absolute value of u sub k, and you find the limit as k approaches infinity, if this limit is less than 1, then we know it converges absolutely. So the same comparison with the ratio test, all right, we did for regular series. If the limit is greater than 1 or it's infinity, it diverges, all right, it diverges. Again, if it equals 1, it's inconclusive, we don't know anything. So here's an example where they want us to use the ratio test for absolute convergence to determine whether the series converges or diverges. They're not asking us to check for conditional convergence, just if it converges or diverges. All right? So again, I'm going to take my a sub k plus 1. Again, I'm doing the absolute value so I can drop that alternator. So 2 to the k plus 1 divided by k plus 1 factorial. So again, with the ratio test, you're looking at the absolute value of u sub k plus 1. You're dividing it by the absolute value of u sub k. So you can drop that alternator. So again, I'm going to find the limit as k approaches infinity of 2 to the k plus 1 divided by k plus 1 factorial. I'm dividing it by u sub k, which means I'm multiplying by the reciprocal of k factorial divided by 2 to the k. So again, like we've been doing, I'm going to split this 2 to the k plus 1 up as into 2 to the first times 2 to the k. Rewrite k plus 1 factorial as k plus 1 times k factorial times k factorial over 2 to the k. Simplify. So the limit is k approaches infinity of 2 divided by k plus 1. What can you tell me about this limit? The limit is going to be equal to 0. So by the ratio test, I know that 0 is less than 1. So what do you know about the convergence of this particular, it's going to do what? Converge. And it converges absolutely. Okay? Any questions on that? Guys, go ahead and do B for me on your own.